This lesson is learning how to find the arc length. Arc length is the distance between 2 points, whether you have a curve or whether you have a line. So let's start off with just a line. And let's say that I want to find the distance between these 2 points here. Let's say that the points are 1, 1 and 3, 2. You learned a formula a long time ago that the distance was the square root of subtracting the y's squared and subtracting the x's squared. So in this case, it's going to be the square root of 2 minus 1 squared plus 3 minus 1 squared, and you get the square root of 1 plus 4, which is square root of 5. So that's the distance between 2 points, as long as it's a line connecting the 2 points. Now, if you were looking at a curve, and I wanted to find the distance from this point A to this point B, then I can't do it quite as easily. I could estimate what the distance would be using that formula and find the distance between A and B in that line. But I really just want to find like the length of that curve. Like if I spread it out, I want to see how long it would be. One way that you can do it is you could make little line segments all the way through. Like I could find the distance between those 2 points, the distance between those two, and just kind of make little lines and find the distance of each of those lines. And then once I do all of that, and if I add them all together, then that would give me the arc length, which is the length of that whole entire curve. Now, what we're going to do is we're going to use an integral to add up those distances together. So we're going to find the distance of one of those little lines, except we're going to make the line really, really small, because the smaller I make it, the closer I'm going to get into what the real answer is going to be. So we're going to make it really, really small, and we're going to add them all together using an integral. So let's just talk about adding them all together. If I do that formula I just gave you, I'm going to write the x's first just for the sake of what I want to show you. That's the same as the change in x squared plus the change in y squared. That little triangle x and y, they're just talking about the change. So that's another way you can write it. Alright, so that's the distance between two of the points. That's not really the arc length, but let's just work with that a little bit. The next few steps, you're not going to know why you would do what you would do, but I'm trying to show you how to get to the formula. So what you could do is you could factor out the change in x squared. You'd end up with 1 plus, right, if I take out change in x squared out of that change in y, you end up with something that looks like this. Alright, and then I can separate that and I could find the square root of each of those things. Alright, and then that's the square root of 1 plus, alright, change in y over change in x. I realize I wrote a y there, that's really an x. Change in y over change in x, that's the slope, or the derivative. So this is the same as the derivative squared right there. And then this represents the change in x, because the square root of change in x squared is change in x. We're going to let that represent dx. And what that means is we're just going to find little bitty segments and we're going to add them all together. And we're going to do the integral because the integral adds them, and it's going to be from a to b. This is the formula. And you're going to use that formula on all the problems that you're going to be looking at. So we're to something else that you need to memorize. So let's look at some examples. Let's say that you have y equals 4x, which is just a line, and you want to go from x equals 0 to x equals 3. and I want to find the length of that curve. Now you can do it, you could graph it and you could look at the points and you could do the distance, but let's just use the formula just so that we understand it. The arc length is going to be the integral from 0 to 3 of square root of 1 plus the derivative squared. And the derivative in this case is 4, so it would be 4 squared. So we get the square root of 1 plus 16, which is 17. This is a no calculator question, so I'm going to actually continue working this out. The integral of the square root of 17 would be the square root of 17 times x, and we evaluated at 0 and 3. So that would be 3 square root of 17 minus 0, so 3 square root of 17 should be the arc length. Again, you could graph it and you could find the distance between the 2 points, but that's the process if you don't do that. Okay, let's look at another one. And we're also going to do this one with no calculator. I just want to practice taking antiderivatives with you. Let's say that you have y equals x to the 3 halves, and it's going from 0 to 4, and I want to find that arc length. Okay, it's going to be the integral from 0 to 4, square root 1 plus the derivative squared. Alright, the derivative of that is going to be 3 halves x to the 1 half, and then I square it. Alright, if I'm working this out algebraically, okay, squaring the 3 halves would give me 9/4. Squaring x to the 1 half, you multiply exponents, so you just get an x there. And then to solve that, you're going to have to use u substitution. I'm going to let u equal 1 plus 9 over 4x. So du is 9/4. That means I need a 9/4 in, a 4/9 out. And that gives me 4/9 integral 0 to 4 square root of u. So now I want the antiderivative of u to the 1 half, which would be 2/3, leave our 4/9, times u to the 3 halves. Then I have to evaluate at 0 and 4. You think this wouldn't be on calculator? Yeah, right, this would be on the non-calculator part. Alright, so we've got 8 over 27 times, I'm going to plug in the 4. 9/4 times 4 is 9. And then again we have that 8 over 27. Plugging in 0, so you just get 1. You could leave the answer right there if you want to, or you could rewrite it as 8 over 27 times 10 to the 3 halves minus 8 over 27. Alright, let's look at a calculator question. Let's say you have y equals e to the x, and I'm coming from 0 to 2. That would be the integral from 0 to 2. Square root 1 plus the derivative of e to the x. The derivative of e to the x is e to the x. Square it. This is a problem that you cannot do without a calculator, so you would just plug it in. Go to Math 9, plug it in. Make sure you try it, make sure you understand, and you get 6.789. Last one, let's say that you have y equals tangent of x. You're going from 0 to pi over 4. Be sure that you're in radian mode. So this is 0 to pi over 4 times the square root of 1 plus the derivative of tangent, 1 over cosine squared. That might be hard to remember. And then square. So you find the derivative and then you square it. All goes underneath the square root. Make sure you try this one in the calculator just to be sure that you understand how to put it in. And I got 1.278. Okay, here's some try problems. There's 3 of them. Do them on a separate sheet of paper. and I want you to find the length from the first x value to the second. Okay, there's your problems I want you to try. Don't forget to finish test corrections and do those 2 free response questions.